One of the important factors fostering climate change is the way we, as a human being, are producing and consuming the energy we need. Energy can be seen as one of the main basic needs of human life since we cannot think of a world without energy anymore. There are several solutions for the green production and usage of energy, like hydrogen and formic acid using renewable energy sources. The urgence for hopeful monstrosities, as explained in the strategic niche management, is increasing in time. Niches can be explained by protected spaces that allow the experimentation with the co-evolution of technology, user practices, and regulatory structures, and are according to the strategic niche management framework crucial for bringing about regime shifts. The hydrogen movement has been in progress in the past quarter century. Especially Japan has a leading position in the hydrogen economy. The Toyota Mirai, together with Honda Clarity and Hyundai Nexo, are the only three hydrogen-powered fuel cell electric cars on the market. Formic acid as an energy carrier has been introduced in the late 90s. In and around 2016, several professors and experts have stated that formic acid is the future fuel for vehicles due to its preferable properties. The year before, 2015, the startup Team Fast was honored with the Brains Award due to their breakthrough of formic acid fuel bus as a high potential technology. Although the great potential, it seems like research on this alternative has been stagnated. To specify where we are now, main hurdles of the breakthrough of both hydrogen and formic acid are analyzed in this research. The properties of the hydrogen atom make it unique in its usage. It is the most common, lightest, and simplest element in the universe. To compare, the energy content of hydrogen equals 120 megajoule per kilogram, while automotive gasoline or diesel only reaches an energy content of around 45 megajoules per kilogram. For the production, using renewable sources, wind-driven and solar energy-based methods are commonly used. However, most of electricity for the hydrogen carrying is still produced using non-renewable sources, creating environmental disadvantages. For the understanding of the developments, it is important to look at the technological and market niches. Technological issues are the inflammability and especially the infrastructure for the hydrogen economy. Industrial ports are needed for upscaling, resulting in lower costs. Other technological drawbacks are shown in the figure. The main drawback of hydrogen production are the costs. To lower the costs, the application of renewable resources has to be studied. However, currently the costs of using hydrogen as an energy source are mainly associated with the grid. The scheme in the slide represents main hurdles which can be identified on the market niche. Using formic acid as an energy carrier to selectively release hydrogen for electricity generation by fuel cells is, according to several studies, a promising alternative to meet the current energy demand worldwide in a sustainable way. Formic acid is an elementary chemical that is a common byproduct in biomass refining. Formic acid notes a high energy density, eco-friendliness measures, easy storage and transportation, and high reaction kinetics. Tremendous efforts have been made in order to put the formic acid fuel cells into practice. Formic acid-based hydrogen storage systems can be produced in different ways, shown in the slide. The bicarbonate formate system is the most preferred one due to thermodynamical measures. Hurdles addressed in the technological niche are availability problems of formic acid and long-term stability of catalysts. The applications of fuel cell still needs to be studied in order to find the less costly one. The market niche still needs to capture legislative actions and lowering prices. According to Müller, economics of formic acid in terms of the entire landscape still needs to be discovered, as it is difficult to find an optimal situation. One might conclude that economic viability and easy deployment, especially for current hydrogen production and usage, still needs to be improved. From black to light gray in the slide, the progress of breakthrough is expressed. Black means that it has already been covered or achieved, while light gray refers to requirements still under development. Recommendations for upscaling are listed in this slide, but the one of main importance is to create momentum over time, referring to both strategic niche management practices as the underlying multiple level perspective. Increasing momentum means that supportive opportunities for upscaling are being created by increasing confidence and decreasing costs. Creating industrial ports, improving fuel cell vehicle competitiveness, and finding a transportation route for the kickstart of trade can help doing so. Surprisingly, creating momentum over time is still needed, while the niches have already been created and active since last century. In this sense, the use of hydrogen and formic acid are rather alliances than competitors. The breakthrough for both requires a systematic approach and upscaling practices for mass production of hydrogen and energy storage. According to several studies analyzed in this Factpod, the urgency is high, the pressure is on, both government as the industry has to create momentum, don't be shy, take the risk, and ready for takeoff.